is one of the methods used to solve some problems in differential equation. And understanding these rules will make the problem being simple and easy to simplify. It said the product rule, if y is equal to uv, and the formula given is dy dx is equal to v du dx plus u dv dx. But naturally there is a little definitions of product rule. And how does it even works? How could we even get it? What's the meaning of u? What is the meaning of v? Let's deep into this lecture. Watch it to the end. You're able to gain more about this course. Product rule in differential calculus is used when two functions are multiplied together. Formula: if y is equal to uv, where u and v are functions of x, then dy dx is equal to v du plus u dv dx. So let's start solving by having first example. This is example 1. It said, if y is equal to x raised to power 3 e raised to power x, find dy dx. What you are going to do is solution. Let u equal to x raised to power 3 and v equal to e raised to power x as its uv. Let's differentiate the u dx. It means we differentiate with respect to x. We have 3s squared and dv dx is equal to e raised to power x. So when you differentiate exponents, exponential values, it will give you the same value. So let's now apply the formula, and the formula says that dy dx is equal to v du dx plus u dv dx. Let's try to substitute the value. Now, what is the value of our v? Our v is e raised to power x. That is our v, e raised to power x to multiply. That is v du dx. And du dx is 3x squared. Now, plus our u is x raised to power 3. Now, to multiply dv dx is e raised to power x. Now, in view of this, we have 3x squared e raised to power x plus e raised to power x raised to power 3. So, let's try to find, it said dy dx is equal to, so we try to make e raised to power x as a common value. So we have 3x squared plus x raised to power 3. So this is a very good example of product rule in differential calculus. We can also have an example 2 that make this topic meaningful, that if y is equal to 2x plus 1 onto the value of x squared minus 3. So find dy dx. So as we're able to say, we don't need to waste much of our time any longer. You realize that we have a u, we have v. So let's differentiate the u. We have du dx will give us 2, and dv dx will give us 2x. In applying the formula so far, which is dy dx is equal to v du dx plus u dv dx. So let's try to apply it one by one. To have our v is s squared minus 3 to multiply du dx is 2 plus, now our u is 2x plus 1, 2x plus 1 to multiply dv dx, which is 2x. So you said dy dx, in better simplification, let 2 comes out, we have s squared minus 3, now plus 2x onto 2x plus 1. Now, let's try to expand to have 2s squared minus 6 plus 4s squared plus 2x. Let's collect the like terms to have 2s squared plus 4s squared plus 2x minus 6. So we have 6s squared plus 2x minus 6. So this is the final answer for that example. So let's still go further to have a meaningful example, as you can able to see. Now let's go to the example 3. In example 3, as we can see, we said uv, as we have started from the beginning, that du dx give us 2x and dv dx give us cos x. In apply the formula so far that dy dx is equal to v du dx plus u dv dx. Now, our v is sine x to multiply du dx, which is 2x. Now, plus our u is x to multiply dv dx, which is cos x. Now, we have, it is s squared, sorry, the u dv dx. So therefore, we have the y dx is equal to 2x sine x plus s squared cos x. So with that example, that is just how it's easy to solve by applying the formula. This is example 3. You said our u is s squared and v is log x or ln x. That's how you call it. Now, we have du dx is equal to 2x and dv dx. When you differentiate ln x, it surely give you 1 over x. You write out the formula again to have dy dx is equal to v du dx plus u dv dx. Now, let's try to substitute the value. Our v is ln x. ln x to multiply du ds is 2x plus u dv. Our u is s squared to multiply the derivative of v, which is 1 over x, whereby dy dx is equal to 2x ln x plus the x we cancel, this x we cancel one s, it will remain x to give you this. So this is the final answer for this. So let's still try to do one example more. Now the example 5, it said if y is equal to x root 2x plus 1, let's represent u by x and v by 2x plus 1 all raised to power half. Now let's try to differentiate one by one to have du dx is equal to 1, and dv dx will give you 1 over 2. You rewrite it according to the composite rule, plus 1 all raised to power half minus 1. So telling you that dv dx is equal to 1 over 2. Now to multiply 2, 1 over 2 onto 2x plus 1 raised to power minus half times 2, and it will cancel, which will give you 2x plus 1 raised to power half. Now, so we now try to apply the formula to have dy dx is equal to v du dx plus u dv dx. Now, our v from the question is 2x plus 1 raised to power half to multiply, this is v, so to multiply the u ds, which is 1, plus our u is x, to multiply the v dx, which is 2x plus 1 raised to power minus half. Now, let's try to write better to have raised to power half plus x over 2x plus 1 all raised to power 1 over 2. What we need to do is let's have an LCM of 2x plus 1 raised to power half. Now, 1 in 2x plus 1 raised to power half, we give all the same answer. So we need to multiply it together to have 2x plus 1 all raised to power half to multiply 2x plus 1 raised to power half, now plus x. Therefore, let's try to choose one base according to the laws of indices that says that if a raised to power m to multiply a raised to power n, you choose one base to have m plus n. So therefore, we have 2x plus 1 raised to power half plus half plus x to divide 2x plus 1 raised to power half. So in overall, we have 2x plus 1 raised to power 1 plus x to divide 2x plus 1 all raised to power half. So recall that a raised to power 1 is the same thing as a. Therefore, 2x plus 1 plus x ought to divide 2x plus 1 all raised to power half, which is 3x plus 1 to divide, and half means square root of 2x plus 1. So telling you that the derivatives of dx of x root 2x plus 1 will give you 3x plus 1 all over the square root of 2x plus 1. So thank you for taking your time to watch this video to the end. Try to subscribe to this channel and for the next topic that meaningful in calculus.